In this lesson, we are going to be discussing the multiplication and division combination of functions. Remember that a combination means performing ordinary algebraic operations between two functions. Now, given f of x and g of x, the product, which is f multiply g of x, will give us f of x multiply g of x. The division or quotient of both functions will give us f divided g of x, which is equal f of x divide g of x. Let's take an example. If you are given that f of x is equal s squared minus 1 and the g of x is given to be 2x plus 3. Now find the product of the functions, which is fg of x. Also, solve for x equal 2. Solution. Now for the first part, we have that our fg of x will give us f of x multiply g of x, which will equal f of x is x squared minus 1. So we are going to have x squared minus 1 multiply g of x, which is 2x plus 3. Okay, now we can expand, right? If we expand, we are going to distribute these, multiply this, will give us 2x raised to power 3. X squared multiply 2x will give us 2x to the power of 3. And this multiply this, which is x squared plus 3x, will give us plus 3x squared. And we are going to have that minus 1 multiply 2x is going to give us minus 2x. And minus 1 multiply plus 3 is going to give us minus 3. So we have the product of both functions. Let's now solve for x equal to, alright, which will be f of 2 that is f of g, fg of 2, fg of 2, which will give us, anywhere with cx in the function, we replace it with 2. So we are going to have 2 in 2 to the power of 3 plus 3 in 2 to the power of 2 minus 2 multiply 2 minus 3. All right, this will give us 2 to the power of 3 will be 8. 8 times 2 will be 16 plus 2 to the power of 2 is 4. 4 times 3 will be 12 minus 2 times 2 is 4 minus 4 minus 3. So this will give us 28 minus 7 because minus 4 minus 3 is minus 7. So we have equal 28 minus 7, which will give us 21 as the final answer. Let's take another example where we have that our f of x now let's solve for division. Given that our f of x is equal x to the power of 2, okay, you may pause the video and try this out. F of x is equal x squared minus 4, and our g of x is equal x plus 2, and you are asked to find f over g of x. All right, now solution for this. We know that our f over g of x is equal f of x all over g of x, which will be equal x squared minus 4 all over x plus 2. If we look at the numerator here, we'll see that we can break it down further so that we are going to have that x squared minus, because we can break 4 to be 2 squared, 2 to the power of 2, which will give us 4 all over x plus 2. We can rewrite the numerator as difference of squares, right? So that we have x minus 2 squared all over x plus 2. Now, having done that, let's continue the equation at this part. We are going to have that for the denominator, we know that our x here, x plus 2 cannot equal 0. Remember the restrictions, you can't divide by 0. And for this not to equal 0, our x cannot equal minus 2, right? Because if x is minus 2, if we replace minus 2 with x, we are going to have minus 2 plus 2, and that will give us 0. So let's make sure that we keep the restrictions in mind. Now, if we continue, we are going to have, if we expand this difference of squares, we are going to have that our x minus 2 and x plus 2, that would give us the numerator all over x plus 2. Okay, we'll see here that this can cancel out, so that this will give us the final answer, will give us x minus 2. That is our final answer, or we can have the value of x to be equal 2. All right, if that is the case, let's solve for x equal, let's take solve for x equal 3. Now for us to do that, we know that our f over g of x gave us the value of x minus 2. All right, so that our f of g of 3 would give us, anywhere we see x in the function, we'll replace with 3. So we are going to have 3 minus 1. The answer will be, 3 minus 2. The answer will equal 1. So x of 3, when x is 3, this quotient combination will give us 1. But we can check to see if that is correct. If we try to replace in each of the function where we have that our g of x, let's check and see if that is correct. If we check, we have that our f of x is x squared minus 4. All right, if we replace the value of 3, so our f of 3 will give us 3 squared minus 4, which will equal 3 squared is 9. 9 minus 4 it will give us 5. Okay, let's check for g of 3. All right, so we know that our g of x is equal x plus 2, right? That is g of x. So our g of 3 will give us 3 plus 2, okay, which will give us 5. All right, if that is the case, let's see that our f of all over g of x, okay, that is of 3. Let's see what is going to give us, since we have calculated each to have 5 all over 5. The answer will give us 1. So our initial calculation was correct.